helpful way to represent motion is often with a graph. Not only does the graph show a scientist a visual representation of the motion, but certain values can also be derived from the graph by finding the slope and area of the graph. In calculus, we call finding the slope differentiation, and we call finding the area integration. The first type of graph that we will look at is the displacement versus time graph. In a displacement versus time graph, the slope of the graph represents the velocity of the object. The slope can be found by calculating the rise over the run, and if the line is going up, it is a positive slope or a positive velocity. If the line is going down, it is a negative slope or a negative velocity. A positive velocity simply means that the object is traveling to the right, and a negative velocity means that the object is traveling to the left. Find the velocity for each section of the graph below. For each, be sure to give a positive or negative sign. So first here we've got a displacement versus time graph. And it shows that in this section, this part A, that the line is going up. That is a positive slope. Now to calculate the velocity, we simply find the slope of the line. And the slope is always the rise over the run. How much it has gone up by how much it has gone over. Now to figure out how much it has gone up, we started at -10 and we ended at +10. So we subtract those two values, +10 minus -10, and that's the rise, that's how high it went, and then the run is how far over it went. Okay, so the rise is how high it went, and the run is how far over it went. And it went from 0 to 2, so subtract 2 and 0. This comes out to be 20 divided by 2, or +10 meters per second. Velocities are always meters per second. The description of the motion is that it is moving to the right. We know it's moving to the right because the line is going up. It has a positive slope. We also want to give a bit more of description in that we want to say if it's a fast speed or a slow speed. Now the steeper the line, the faster the speed is. So this line here is rather steep. Think of it like a hill, and if you were to roll a ball down the hill, if it is a steep hill, it would roll fast. So here we have a very steep line, therefore we consider this a fast speed. To calculate for part B, that is this section here, again we do the rise over the run. Now the rise part, how high it went from 10 to 10. And the run part, how far over it went from 2 to 5. So it didn't go up at all, and it went over 3. So our answer is 0 meters per second. Notice that the line is flat. So just like that ball description, if I were to put a ball on this line, it wouldn't roll at all. It would not be moving. So the description here is that when the line is flat, the object is not moving. It has a 0 slope and therefore a 0 velocity. The last section, part C, the line is going down, and again we want to do the rise over the run. Now the line went from 10 down to 0, and we also have that it went over from 5 to 10. So it went down 10 and it went over 5, which gives us a slope of -2, and it would be meters per second. Now notice the units here, also it's the rise over the run. It's a meter over a second. Here, because it is going down, because it's a negative slope, we see that the object is moving left. And this is a relatively shallow slope. It's not steep, and so it is a slow type of movement. What I'd like you to do in this next section here, I want you to give the video a pause, and I want you to try and calculate the velocity, meaning the slope, of each of the sections in this line. So go ahead and pause the video, try the calculation, and once you've calculated them, unpause the video and see how well you did. Okay, let's go over these calculations. For part A, we have that the line went down from 10 to 6. And we have the line went over from 0 to 4. So it went down by 4 and over by 4. That gives us a velocity of -1. And don't forget your units, meters per second. Our description is that it is moving left because the line went down, has a negative slope. And also, it's a relatively slow speed. When looking at the other lines here, the other lines are rather steep compared to that one. In part B, we have that the line went from 6 to 6, and it went over from 4 to 8. So we can see that it is a horizontal line, it's a flat line, and therefore there is no motion. It is not moving. The next part, part C, we see again that the line is going down, starts at 6, and ends at -6. How much it went over? It started at 8, and went over to 14. So we have it went down by 12, and it went over by 6. Our slope or velocity is -2 meters per second. Here we see again that it is moving left, and we know that because the line is going down, and it's a relatively fast motion because that line is a lot steeper than line A. The very last line, line B, you see now that the line is going up. It started at -6, and it went up to +12. We see that it went over from 14 to 20. So it went up by 18, and it went over by 6, which gives us a slope or velocity of +3 meters per second. Because the line is going up, we know that it is moving to the right. And the slope is pretty steep, so it's a relatively fast motion.